Hello. This video is going to take a look at defining the system inside of interactions. The system is composed of the different objects that store the energy. And there's two different types of systems within these energy interactions. One is a closed system. A closed system has no energy flowing into or out of that system. In other words, all of the objects that are involved within the system have all of the energy stored inside of those objects, and even though the energy may change storage within those objects, it all remains within those objects. And we'll go through an example of some closed systems here in just a moment. But the main idea is that the system has all of the energy to start with in some storage type or the other, and that total amount of energy stays within the system. An open system has energy that flows into or out of it, meaning that even though the total amount of energy in the entire universe is constant, the energy storage inside of the objects in the system may not be constant. The system may exchange energy with the surroundings, and that's one thing that's really not defined in this. The surroundings, just want to write that down for a moment, consist of all of the objects that are not inside of the system. So I'll try to use that word too as we go through a few examples here, and we'll define some closed systems and some open systems for some different interactions. So let's just take a look at these. So this is a worksheet that is out on Canvas. It is called Choosing the System. If you want to kind of go through this afterwards, I will come up with another version of this also, and I will call it Choosing the System version 2 or something like that. I'm sorry I don't have it created yet, but I will do that shortly. It should be pretty obvious under what's in Canvas what the other one is, and I will be posting answers for that out on Canvas also, so that if you do the second one, then you can kind of check through and see if you're thinking correctly about either closed or open systems. There's a reason we need to decide if the system is closed or open in terms of modeling, and I will get to that real shortly at the end of this video. So for each of these, there's 4 situations on this little practice. Right, I want to first of all select all the objects necessary to make it a closed system. In other words, all of the energy will remain inside of those objects in some type or the other. Choose an object or two that we can maybe pull out of the system and have it be the surroundings instead, so that there is energy exchange going back and forth in terms of the energy storage, but it's not all just inside of the system. And then if it is the open system, we're going to make sure that we identify where the object's being stored that is entering and leaving the actual system. So here's the first example I've already done. Suppose a ball is lifted up and held. So the ball starts on the floor or a table. It is lifted up and held some distance off of the surface it was picked up from. Right, so to be a closed system, it needs to include the person, the ball, and the earth. Because if the ball is going to be lifted up and held, it has to be lifted up by something. In this case, that would be the person. All right, and we talked about energy. Energy involves some sort of change. Right, so definitely the person is going to change what is going on with the ball. Right, so in terms of energy storage, so the person has to be part of the system. Hopefully, obviously, the ball is going to be part of the system. The earth is going to be part of the system because as this ball is lifted up, it is changing the amount of gravitationally stored energy inside of that ball. Once again, I should have mentioned this at the beginning. If you have not watched the video called Basic Energy Storage to look at the different energy storage types, you will need to do that. You should probably actually just pause this now or stop this video and go back and watch that one. Once again, it's posted on Canvas under energy storage and energy models, so you can go back and take a look at that so that the rest of these definitions make sense further down. But in any case, this is going to have gravitationally stored energy, so the earth is going to be involved in the system also. If we include all 3 of those objects, all of the energy interactions, all of the energy types as they change from one type to the other are going to be represented just with those 3 objects. So that will be a closed system. On the other hand, if we want to open the system, the open system might be just the ball and the earth. So those will still be 2 objects. Well, there is going to be some energy storage in this interaction. However, for this open system, there is no way for the ball to be lifted up and held. Right? So if I make the open system just the ball and the earth, the person, right, is going to be pulled out of the system. The person will now be part of the surroundings, but they are going to have energy that's put into the system so that the ball can be lifted up. That energy is going to be chemical energy from the person, right? So if the system is open, the person is going to be part of the surroundings, and they're going to add chemical energy to the system to actually get the ball to lift. So within a closed system, that chemical energy would be part of the system and it would stay there. For the open system, the energy is kind of outside of the system initially, and it's entered in. In our next video, we're going to talk about some things with the energy bar charts, and I will actually do energy bar charts for all for this and the other 4 examples, right? And we'll see the difference between the closed system and the open system. So, number 1, a ball is kicked across the floor and it eventually rolls to a stop. So if a ball is kicked across the floor, there has to be a person that is kicking the ball. There's going to be the ball, so I should slide this up a little bit, that is kind of the main object that is under study, so that is going to be part of the system. And if it rolls to a stop, it is going to be the floor interacting with the ball that is eventually going to stop it. So the floor has to be part of the system also. So if we include those 3 objects in the system, right, we should be able to account for all of the energy interactions. Once again, if I choose maybe just the ball and the floor, that will explain the second part of the interaction. But if I take the person out of the system and put them in the surroundings, once again, they are going to have to add some chemical energy into the system to get the ball to move. I'm not going to write complete answers on this because I'm trying to write large enough so you can see what's going on. However, it would be nice, once again, you said for this open system, the person must add chemical energy to the ball to begin its movement or something like that. Okay, if a ball rolls down a hill and stops, we have the ball. We have to have the earth because the earth is what gives the ball the gravitationally stored energy at the top of the hill. And I'm just going to call it the hill surface, the surface of the hill, right? The ground, you can call it whatever you want, which is actually different than the earth, right? This is actually the surface the ball is rolling along. That is what's going to stop the ball, right? So there's going to be some friction between the surface of the hill and the ball, which is what's going to stop it. And so once again, it's changing the motion of the ball. So since it changes something about the ball, it's got to be part of the system. What I could do, there's a few different things I could do. I could pull the earth out of the system. Oh, excuse me. Wrong part here. I could pull the wow, I can't talk either. Sorry. I could pull the earth out of the system, leaving the ball on the hill surface. There we go. That's what I meant to say to begin with. And if I do that, right, the earth will have the gravitationally stored energy outside of the system to start with. It will go into the ball, and then the ball can start rolling downhill, and then once again the hill surface will change the energy storage from the gravitationally stored and kinetically stored in the ball, and once again we'll kind of look at that in some diagrams here shortly, and that will change that into thermally stored energy. And so we'll get there. Number 3, a rubber band is stretched and shot upward to the top of its path. A couple of things about the top of something's path. At the top of its path, right, all of the energy is gravitationally stored and none of it is kinetic or kinetically stored. Which once again, sorry, it's been a little while. I've kind of gotten a little lazy, right? This should not really be chemical energy. It should be chemically stored energy. We're going to try to use the word stored with all of these. Once again, if we're going to include everything, the person is going to be the person that is stretching the rubber band, right? We have the rubber band itself. And as I said, at the top of its path, it's got gravitationally stored energy, so we need to have the earth in there again. Just like the first couple of examples, we could pull the person out, leaving the rubber band and the earth as the system. And once again, there's definitely energy exchange going on between those, right? Between energy storage types. However, if we take the person out of the system and move them into the surroundings, they have to have chemically stored energy initially that we will be adding kind of into the system that will then be interchanging between the rubber band and the earth, between the other forms of energy. We'll find out in a little bit. There will be some kinetic, there will be some gravitationally stored. It depends upon which part of the interaction we're looking at. And once again, we'll do some energy storage diagrams for these in just a moment. And finally, last but certainly not least, a ball is dropped and bounces until it stops. This says ignore the lifting part. So again, we have the earth, we have the ball, and I'm going to assume it's the floor and not the ground necessarily. Once again, the earth and floor are different things, right? The earth is going to be involved with the gravitationally stored energy of the ball initially, which is going to change as the ball falls, but the floor is definitely going to change the motion of the ball also. So the earth and the floor are two different things. The earth is having the gravitationally stored energy making the ball fall down. The floor is what's pushing the ball back up again. So once again, I could just leave the ball and the floor as the system, and if I do that, there's definitely energy interchange going on between those, but the earth would be the thing giving the initial gravitationally stored energy. So for all of these examples, right, if we choose the system broad enough, we can make sure that we include all of the energy within those objects for the entire interaction that's going on. However, we can pull out some individual objects, and if we do that, right, our system is a little bit more narrow, and if we do that, we haven't maybe included absolutely all of the energy interchange, right? Part of it, and unfortunately with these examples I chose, it's always the initial part where some extra energy is added into the system. However, it can also be an open system where in the middle, at the end, it depends upon the interactions, some of the energy leaves the system. Now, there were a couple of problems initially where I said, friction and thermally stored energy leaves the system. Well, if we have the Earth as part of the system, right, that energy really doesn't leave the entire Earth. It might leave a couple of objects in the system, but since it's still within the Earth, I'm not sure thermal is the best thing to say that is ever really leaving the system, unless we're looking long enough in the future where that thermal energy has actually even left the Earth, right? But initially, if we're doing something, and we'll find out in a couple of these there's some thermal energy, it might have left an individual object, but it's still on the Earth somewhere. So what I want to do next is actually stop this video, so it's not really too long. We'll go to a completely separate video, and we'll take a look at some energy bar charts. And what I will do is actually go through these examples first with those. At the very initial part of that video, I will probably also talk about the difference between the energy pie charts and the energy bar charts. So stay tuned for those videos, and they'll be coming up next. Once again, they'll also be posted out on Canvas, and it should be obvious once you look at Canvas where to find those and the titles of those videos. Thanks for watching.